And we're live. Hi, good morning. Hi, all. We have Nazerke Turtayeva, PhD student at University College Santa Barbara in California, former student researcher at Google Brain, which is Google's machine learning, AI, and other research focused department. Alina Achilova, Google Developers Group Almaty organizer, and IT business analyst at Air Astana, Eastern Europe's leading #1 airlines company. And thank you for joining today. If you
Thanks for inviting.
Thanks for this is early morning in Asia and super late evening in California. Thank you, dear ladies, for having time. Oh, we even have one person who is watching in YouTube. Hello, one watcher. If you want to ask questions, you can type in comments here like hi, and we will put it on screen. Those who are watching recording, you can also type in the comments in recording, and then we will chase speakers, and if you ask them a question, we will ask them and write a reply, and don't hesitate. We already rehearsed a little bit. Nazerke prepared a PowerPoint deck with Google slides about, we were discussing the PhD journey. Nazerke is doing, I think, most difficult research from all speakers we had this year. Nazerke is the most sophisticated related to hardware, chips, the infrastructure which fuels AI. As you know, to train, we need a lot of hardware. And we asked Alina, we asked Nazerke to share some tips for PhD students, and also Nazerke wanted to tell about difference between internships in Google and Google Brain. And please, Nazerke, the mic is yours. Thank you.
Thank you. Thank you for the introduction. Yeah, let me pull out my presentation here then. Upload file. Yeah, so it's like PowerPoint format. Is it good, or it should be on like Google Slides?
No, it's no problem. You can just share all browser screen, and we will put it here.
Yeah, it's processing.
It's PowerPoint, yeah. If it would be Google Slides, it would be immediately.
Yeah, I guess. Okay, can you see it right now?
Yep, fine. Yep.
Great.
Yep.
Yeah, so here I would be talking about academic life and internship differences, and if we're gonna have some time, then also about computer architecture research. So in general, a bit of background. It shows everything at once. Okay, so I did my undergraduate at Nazarbayev University, Astana, Kazakhstan. It's such a great place to be in, and I definitely learned a lot from my peers and made a lot of friends. And also, following my bachelor's graduation, I went to the PhD program at the University of California, Santa Barbara, in electrical and computer engineering. So this is my second year in my journey. And I also did Google Student Researcher Program at Google Brain for 6 months during this academic year. And this is essentially where I met Askar. So here, as we can see here, there's just like some information about UC Santa Barbara. It's one of the nation's leading University of California universities. So this is interesting set of network of universities, which includes like 9 universities and 1 medical school. Only in California, and this university also has a lot of people who a lot of startups that are being bought by different companies. One of the famous one is a graphic startup recently acquired in 2017 by Amazon's Alexa team, and a lot of cool professors. Like if you talk to them, they all have some stories of, oh, I made this startup and it's been bought by Siemens or like some other company around the earth. And there are some Nobel Prize winners. And also the city has it's a very small city. It's called like, it's a very touristy city, but it also has some like branches of tech companies like Amazon Knowledge Team, Google Quantum Foundation, Folio, and etc. And we have our own private beach, so it's like 5-minute walk from my office where I'm sitting right now. So it's kind of a promo of my university in case if anyone wants to apply in the future as well. Yeah. So the next slide would be about why to go to PhD, because I wanted to tailor this talk a little bit for more general audience, because I think after you graduate there are so many like career options for people, and one of them is to go to pursue academic path further, but there are so many misconceptions or stereotypes about it, and people just simply don't go to apply to PhD because they have certain not accurate information on how actually it is. So one of the first misconceptions is that research is boring, so hence this PhD, I'm not going to spend my time on it. Or another way is like, oh, you lose so many years that you could instead would spend doing the like work in industry. Hence you also lose so much money because usually PhD is known to having less salary than the industry, because most of the time it's spent on your tuition fees instead. And also you go to PhD because you want to become a professor. And if you don't want to become professors, then you don't have to go, which is also a very huge misconception. And that being a prof is boring or not fun as undergrads, hard to find friends. People don't want to just do homework simply. They don't want to be teaching assistant, which is kind of grading the students' work and being an instructor as well. And people also believe that it's too much stress and competition. But in reality, actually, you can enjoy your PhD a lot. And while I was applying and reading different blog posts, it was like people were actually telling that their PhD duration is one of the vibrant time of their life, because they get to see so many people, so many research ideas, and there will be so many brainstorm and excitement because you are trying to come up with something that does not exist yet, but you are creating that new knowledge. And so it is actually does not have to be boring or formulating one thing again and again. It can be something exciting, implementation heavy, as in my research field, and something related. And also, yeah, accordingly, even though you spend your years, it usually be for something fun, because you do usually when you do like cross projects for undergrads, you feel like so limited because you have to finish it in semester or year timeline. But when you're gonna have your PhD project, you have so much time to research it, investigate it, come up with new solutions, to fail and to come back with new solution again. It's like very exciting journey when you have your own freedom. Like, if I can say this in this way, but I think doing a PhD in some sense or another, it's kind of, or becoming a professor, maybe it's just doing your own startup, I guess, but you just don't have to think about finding money or whatever, but you just do something new as well. And so this is very exciting in that sense. And yeah, actually, even though you don't get paid during the PhD, you always can go to internship to have a comparable salary as in industry, or you can also get paid a lot after you graduate, because usually after PhD you start a little bit differently than if you are graduated from your bachelor's diploma. And actually you can also have access to a lot of exciting projects versus if you would continue after your bachelor's, which is also possible, but like it gives you so much freedom after you graduate. And so yeah, about the main point of going to PhD just to become a professor, you don't have to, because in fact what is happening is that like academic market is so let's say there is so much high competition, so that people end up instead going to industry because it's so hard to get into academia and become a professor. And actually it's a great option as well, because you get paid so much and you don't have to come up with problems, because problems are there and they are real life problems. And usually having a PhD instead will give you access to so many sea of projects, or if you think that you want to be on your own again, then you can create startups, be part of startups or become work in consulting jobs if you decide not to do any engineering research anymore. So there is so much freedom, and it also just gives you those skills of doing and conducting a research and project on your own, which I think would be valuable for so many companies. So it is actually it's exciting and very flexible. You don't have to become a professor. But if you decide to become a professor, then it's also not boring and not that bad. Talking to my professors or like some other friends who became a professors, it's actually exciting in a sense. Like you can choose a university where you're going to be a professor and negotiate your contract so that you can control how much you're going to teach, how much you're going to conduct the research, how much that university is going to fund your research, so that you don't end up like I don't know, finding so much money for your students. Or like you can also manage to have like enough TAs so that you don't have to end up grading so much of your work. So it is very controllable, balanceable, and exciting work. And essentially, people say that if you become a professor, then you do not have a boss as well. You just, especially in US or Canada, you apply to tenure track. After 6 years, you become a tenured professor, after which nobody can fire you. Like in Kazakhstan, for example, NU, people used to have contract for 3 years and it will always renew. But in US, for example, if you become a professor, then you become a professor. Nobody cannot fire you. So that's very interesting aspect. And you do not also give any, I think it's the same in Kazakhstan too, I guess, that you do not give any report to anyone. You just become a professor, manage your students, you don't have boss, unlike in industry. And again, if I can do so, I can compare it maybe to having a startup, because again, you do something super new on the edge of technology and knowledge, and just you do not have to, I guess, sell your product, but you just need some fundings to support your students. Or sometimes if you're in the right universities, then maybe you don't have to think about it a lot because university somehow has a lot of money. So like there is like so many opportunities in that sense. And it is actually a lot of fun in PhD too, like not like you do not do maybe a lot of parties as in undergrads, but you actually can have a lot of friends. They might not be from your major, but they can be from across different majors, because when you go to PhDs, there would be different associations between international students and stuff. So it will be like really so much fun. And actually, as you don't have to do homework too. What in fact happens is that you don't have any midterm and finals. Especially if you're in computer engineering track, or depending on university, I guess, as well, even in master's program, because everything would be project-based, or you just write papers for the papers that you read as a summary. So it is very balanceable, and I think the type of homework that I love versus the quizzes, midterms, and exams and assignments. So it's very cool. And after you complete your master's, essentially you became a full-time student. You do not have to take classes anymore. You can do just for your own fun, and eventually it will be similar as becoming a full-time engineer somewhere else, but you just do not have to be in the office from, I guess, 9 a.m. to 5 p.m., depending on who is your professor. And you can have like more leeway on what kind of projects you can work. So that's very fun. I mean, you can definitely have some stress during the conference deadlines where you're going to submit your papers, but in general, it's very manageable and fun life, I will say. And also, you don't have to be TA forever. TA is teaching assistant, when it's like a position at university which covers all your tuition fees, and also you help a professor to teach a class. And simultaneously you will do your research. But you don't have to be a TA again forever, because especially we are lucky in the engineering or like STEM fields, so that we always have like research assistantship, or we can have fellowships. So we don't have to TA a lot. And you might be required to TA for 1 or 2 quarters, just because you might go to academia, so you need to know what is TAing or giving a knowledge to someone else. But in general, you don't have to. For example, in my department, there was no constraint for me to TA, but because my professor is from computer science department, he asked me to be a TA sometime in the future, because for him, it is important fact of me graduating, and in case if I'll become a professor I should be able to pass the knowledge through being a TA. So as we see, like, you don't have to be TA as well. So there is like so many opportunities. And about stress and competition, I will say that, yeah, it exists there, but I think it might be the same as you will be in industry doing research or like engineering as well, like when it comes to deadlines, and you have to do some progress report, right, in order to be, how it's called, promoted to the next position. So in PhD as well, you just have your like regular conference deadlines where you submit. Sometimes you do not. So it's kind of manageable if you have the right PI, which is principal investigator, or your advisor, and if you have right people, your friends and family supporting you. So like, yeah, but disclaimer, it does not mean that PhD is the best thing that you can do with your life. It is not. For some people, it's just simply not feasible, and it's not what they like. But it's just that when people make this decision, I want people know that actually there are so many opportunities versus what they usually think about PhD, what PhD is. So yeah, this information. If you guys have questions, maybe you can ask it here before I move into the next part of my presentation.
I think usually also internet lag, so the people type questions later. If I have question about this.
You
this
also
called
doing PhD as
Stellar.
well, right?
Yes, but it's kind of part-time, and I'm late. I did it in 2019, and it's finished, but I just need to do paper, Scopus paper. In Kazakhstan, they renew contracts for these academics every year. I know that they not like in US. And seems if you, from what you tell, if you want to do PhD, only right places, US, maybe some Western Europe. I think in other universities it's not like that. Alinda, maybe you have questions, so we can.
Yes, I have a question.
Go to
Thank you,
next.
Nazerke. It was very interesting. So I want to ask about why you decided to do PhD in computer architecture.
I see. It was actually a bit of a long journey of why I decided, and actually, like in the fourth year of fall of my senior year, I think like decision has been changing like every 2 weeks because like there are so many options as I mentioned before, and why computer architecture? Because like I like the class that has been taught by professor. If my friends are watching it, we had a professor called Vipin Kijipat. He's now back in India, but like when he taught us, like it was so cool, and we were like, oh my god! Like literally when he taught the class, I was like, this is like a black magic. Like we never thought about how computers, microarchitecture, or whatever works, but now he explained it. It felt like that. Oh, there is some kind of magic behind, but now it opened and it was so exciting. So I was like, yeah, I want to do something like that. But then I realized that, oh, oops, then if I want to do it, then I have to leave Kazakhstan, which I'm not sure whether I am ready to, because I am very attached to my family and stuff, and also to my country. So, and it was like, oh, then I'm not going to have any job in Kazakhstan, and also it will be a long journey. So I said, okay, I will pose with this plan. But then like I did different stuff after this class, like mobile development, web development, data science and stuff. And I decided I felt like I did not enjoy them as much as I could. And so I came back in my third or fourth year, did some remote Google Student Researcher program with my current advisor. Back then he was my mentor for those like open source hardware projects, and he introduced me so much. And then I knew that actually I can now pursue career in computer architectures, and leaving Kazakhstan is not as bad, and I think there are exciting opportunities. And also I felt like PhD as itself is also a very exciting journey because he shared so much of his own. So I think I got also lucky of the people, these two coincidences of my professor and also my mentor during this open source hardware project.
how open source is made in hardware? In software, as far as I know, you just develop some code, you issue this README file, and you select kind of license, template, some GPU v3, MIT, or etc. That's basically that's it. How about hardware? What's the process?
Yeah, so it depends like what kind of a hardware stack it is. Usually, like when we write a hardware for computers, there is also programming languages for it, which is called, there are multiple of them. One of them is Verilog, System Verilog, VHDL, or there are some others coming this year's like Chisel, Turtle, BlueSpec, so many. And those are like similar to C, but have different syntaxes. Like everything happens in parallel instead of being sequentially. So, and you can just like push this code for your hardware to GitHub in the same way as you push your software code. And you can also use the same like software license for them, because it's essentially at the end of the day text, a bunch of text that you push to your GitHub, so you can open source it in that matter. And it will be just like also a huge code base for your processors and many core processors and different architectures. But when you will move down, when you tape out your chip, then you actually synthesize this code into a gate level logic. And after gate level, you synthesize it to transistor level logic, and you also do some mappings in some other software. And then those part of the hardware code is done by physical designers or by other people, which are not us or me. So, and usually that kind of code is also not pushed into GitHub, so cannot be open sourced. So it's just like upper part of the stack can be open sourced, and this is how it's done in hardware.
Awesome. This maybe could you share some journey how you became PhD? I mean, you shared, but how difficult was to make the initial step? As I understood, you got into this ecosystem of master's degree, and then you got this internship in Google Brain, and then you got this end up in PhD. Just actually two questions. What is Google Brain usually doing? Is it ML research? I know probably it was merged with DeepMind recently from the public news. No? If you could cover what can be shared, what is Google Brain doing, and second, how you got into this, I guess, master's degree, right? For those people who will be watching.
Yeah, I see.
Okay.
So about the Google Brain part, I'm not sure whether did they merged with DeepMind, because they have so different culture at Brain and DeepMind, and they're like naturally competitors for such a long time. But I think they're collaborating now on like one of the projects. I forgot the name of it, but yeah. But maybe you are true as well, because I didn't check the last news, so maybe I'm missing something important, so I cannot guarantee. And about the Brain itself is so it is about ML research, but more about applicable ML research, while DeepMind is more about something not yet applicable but can be huge in the future. For example, I think developing, I guess, like chess player AlphaGo might not be the most applicable thing for the Google servers, but DeepMind did it. But at Google Brain, you're gonna do a lot of research, like for example ML for systems, which does so many optimizations for your like systems at Google and servers, or it can come up with so many exciting researches, like for example transformers, which is what like now ChatGPT is using, or some other so many like large language model startups these days, including Google's products itself. So so it does like a very exciting and super new research on applicable ML to push the knowledge of it. But I am not ML person, right? I'm a hardware architecture person. How I ended up there? Because it was fun, because I had another mentor, which I met in another program, and he was at Google Brain and is currently, but he is also from a computer architecture background, and he switched to it because his knowledge can lead to on making new ML programs. It can inform people to make better machine learning models, right? So that it will be more hardware accurate and better. And also there are some TPU teams that, for example, Google can, I guess, sometimes work with. So yeah, at Google Brain, it's mainly ML jobs, but you can also have some hardware-related projects, like, for example, how to generate hardware for machine learning in optimized way, so that it's certain tasks can be automated already. Because, for example, when you will be coming up with a hardware, there will be so many decision points, like, should I optimize for my area? Then what will be my performance? Then should I optimize for the powers, and what will be my performance? And you have to compare so many of them, and it will take sometimes so much time of the computer architect. But you can just come up with the ML model, so that this generation of the architecture and exploring the design space would be automated. And so this is kind of the hardware related works that are done at Brain. And they had the papers that have been published at, for example, Nature and stuff. And they had some works that is automating not only hardware for ML, but ML itself, and then hardware for ML, which is full software to hardware stack for certain chip software to chip designs. So which is very exciting. And this is kind of some of the works that are done at Brain. I can talk about my project later. Yeah. Was it too much?
When you started to tell about transformers and this complicated math stuff, I saw we had 3 viewers, and then we had one, two people left. Two people left when you started this complicated stuff. For those who are not watching, I actually, because I only know about transformers because I took taking course in this Cloud Skill Boost, and they explains basically mathematical formula which multiplies itself several times, coder, decoder, how to predict which words. And they told on this course that it's actually BERT system, which is transformer. It's actually powering search, Google search, to look for words.
Yeah, this system can be used also for vision. There are some vision transformers too, if you wanna combine text recognition with vision recognition and stuff. So there can be some cool stuff that can be done, and yeah. So I think the second question was about how I ended up doing my MS PhD application. I can talk about it. So about that. As I said, I did some open source hardware project at the end of my third year, and I found my mentor, and then he gave me a lot of knowledge. So I started to apply afterwards when I started my fourth year. And I searched for a lot of options, but I didn't want to spend a lot of money to apply to universities. So I just applied to just some set of universities, only 4, I think. And also my mentor became a professor. So he graduated from Princeton and became a professor at UC Santa Barbara. And he was like, "Oh, I think you did a great progress, and I'm also becoming a professor there. Do you want to apply and see whether you like it or not?" So it was a kind of journey in that sense. And he was like, "You can actually go after master's degree," because I was telling that I don't want to go beyond master's, in the application season. But then I also just as I said, in those 2 weeks, I was like, "Oh, actually, it's not that bad." So I ended up in PhD program in that way. And UCSB ended up to be a great place, and my professor's research was a little bit different than what I expected. If some of my friends are watching, they know that I was being into accelerator design, which is one of the things that you can do in computer architectures. And I was like, I don't want to do anything else. But then I realized that there are a lot of exciting things with system designs that you can do. And so now I am enjoying my research, and this is how I ended up. And for application season, you also apply with you put your personal statement about why you want to apply to PhD, and you also put 3 recommendation letters from your professors, and you put your CV or resume. You put I guess your IELTS exams, and I got lucky because I didn't had to do GRA back then because of COVID. So yeah, that's it. And I think California universities also ask for your like personal history, which is not about your career excitations, like how you grew up and stuff, because they want to do some diversity assessments. But I think some other universities don't do it. Yeah.
Thank you. Awesome.
Yeah, I highly recommend to prepare in advance, like a couple of months before. It will help because and also you have to reach out professors in advance as well if you don't know them ahead of time.
Super. Thank you for this advice. I'm sure people will be applying it if they go to academia. We booked your time basically for 45 minutes, etc. But if you have still a couple of minutes, maybe you have time to share the slides from your research. I know it's super complicated.
Yeah, but I actually have
some power outage in California, not only in Almaty or Tashkent.
Yes. She closed her presentation and powered it off.
She closed this. Okay. Yeah. That happens. I think it's pretty cool. She do research in ocean. Maybe she can go swim. Now it's in California ocean. It's called. I think it's called California weather. Ocean weather today. I'm just googling California weather. I think it's too cold to swim. 54 degrees Fahrenheit. It's minus.
Accidentally shut down my phone. And not phone, my laptops. Sorry for it.
Alina predicted this. She said exactly like this.
Yeah. Okay. Yeah. So what I had is like this presentation part. So it's just like difference between two programs. I can quickly talk about that too. In case so like at Google has different like internship programs, and one of them is like student researcher program, and one is like typical research internship. So usually student researcher is almost the same as research intern, but it's just like non-convertible and very flexible. So that's the difference, because some teams at Google, like Brain, decided to make the research internship only for the like senior PhD or bachelor students, and for others they can just do student researcher program, because they want to evaluate candidates throughout their internship in order to see if they are convertible or not. And if they are not, but if you are not in your final year, it will be extra work for them to do these evaluations for conversion. So that's why they come up with another program, which is student researcher, for students who are not in their senior year. And essentially it will be also like not about it can be about Google's research and Google's product, but you have usually more flexibility of coming up with super new idea as well, and just use like insight of your advisor at Google and some other people in general at Google as well. So, and you can do it both in summer and academic year, which I did like during fall and winter quarters, and it can be both remote and in person, which I did remote because I was studying while I was working, and we did it remotely because during summer my professor wanted me to stay there because it was my first year, and he wanted for me to gain more research expertise. But if we had to wait for another summer, it would be too much. So we had to start in fall in order to make a good progress. And if I would do it research internship, I couldn't do it. But with student researcher program, I had that flexibility of doing my both university and Google research simultaneously.
Question, how to apply? Careers.google.com, right? And
yes.
Second question, usually this researcher for US students only, if you're a US student, right?
This is very sad point, but yes, it is for North America, which I think can extend to Canada too. I hate that certain opportunities, especially in hardware research, is limited only to the North Americas. That's why I had to apply here. I mean, there are great research in Europe, in Southeast Asia, and like KAUST and some other universities too. But like industries themselves, like Google or some other companies, have centers only here. And so programs are also related to here. But I think it's possible in Europe because someone reached me out in LinkedIn and she asked for me a referral because she wanted to do some ML related student researcher program in France.
Cool.
So I think now they are extending, but back then when I applied, it was, I think, only limited to North America.
Thank you, got it.
Yeah.
Still, if someone wants, they can just move to American University and apply.
Yeah.
I just hope to Google Careers websites, so many vacancies in Google according to this career website.
Yeah.
But in US, yeah.
Especially in hardware. Okay, let me see. I can put a lot of hardware stuff research, but if you think that we have to finish right now, then we can finish right now. I'm flexible.
I think we can talk a little bit about your project in Google Internship and what you exactly do in there. And no for details, just overview, like for who want to also do like this internship, maybe it will be interesting, I think.
Yeah. So yeah, when we started GSR program, like we had this like conversations about what kind of project I'm gonna have for a month ahead of time. And also when we started, I had like 2 weeks time because I could see some like confidential projects that my advisor couldn't tell me ahead of time, and so I could choose in between those two. But I choose open source project so that because it can contribute to my like PhD completion later, so that I can put it for my defense as well. And the project is about coming up with like instruction set architecture. So this is a like abstract view between the software and hardware. So when you're like write a program and you compile the code, it will be compiled depending on what is that instruction architecture of that hardware that on which you are running your software. So like it usually is main ISA types are x86 or ARM, right? But when you're gonna build your architecture for the machine learning, then you have different type of hardware, which is called accelerator. And accelerators are type of computers that are only special purpose that can do only single task. For example, doing only convolution and that's it. It cannot do like if else branched code for your, for example, browser. So it cannot be general purpose as your processors are. And so those accelerators have also their instruction set as well, but they are very limited. And usually this instruction set architecture is only developed in the companies themselves and not available to the community, versus some other instruction sets for general purpose computers like RISC-V. If you heard about it, there is some like super well-known instruction set architecture recent years called RISC-V, and they are like very open and standardized for everyone to use. But with accelerators, we don't have that kind of ISA yet. And usually why it's problem, because when you build your accelerator for your brand new machine learning algorithm or large language model, people do it differently. There are some like basic fundamentals, but usually instruction formats are differently, even though fundamentals are kind of similar. So our research at Google when I worked there was like coming up with this ISA so that we can standardize it and publish it later. And so now I finished my program, and now we are thinking to continue it later in next student researcher program and to actually collaborate with RISC-V Foundation based at UC Berkeley. So this is kind of our goal and what we are working with. But so ISA is specification and on how your code should be compiled to, right? In what kind of instructions. But now if you want to test it, you have to also build accelerator. So in my previous student researcher program, I came up with specifications by analyzing the like machine learning and large language model workloads. But now what I have to do into my next program is an ideal also to build an accelerator, write a program, compile it with that like ISAs that we came up with, and come up the bring the performance numbers. Yeah.
It's good.
Maybe we should repeat this, but yeah, with some pictures next time.
Yes, sorry. Like I did not prepare a presentation for on my Google research, which is I think I should with pictures. Yeah, definitely it helps better. Yeah.
Okay. But it sounds really good, or really interesting.
Yeah.
I try to imagine all of this process.
Yeah, it is very interesting and exciting, but also like hardware can be complicated if you don't like it, but once you start doing hardware, it becomes also simple. So it's just like until the moment when you, I guess, go over that hesitancy a little bit. Yeah.
Oh, I think about it that I want to ask question. Did your expectations that your about hardware and also computer architecture come true or meet up after with this now experience?
Oh, I see. Interesting. If it depends with which point of myself I can compare. I'm gonna compare like if high school and right now, no, they do not, because I did not just simply had any expectations. And if I will compare with my undergraduate view, I guess it kind of coincides.
Yes, after that course which you take in NU.
Yeah. I think it coincides like on how hardware research is kind of done a little bit. The only difference was that I thought that like just doing accelerator itself is so cool and I just want to do only that, right? But then when I joined both Google or like my UCSB research, it turns out that like writing accelerator is something possible. But what is hard is actually to connect different accelerators to each other together, or to come up with models that are best run and coordinated in different type of accelerator. So this is something new that I realized. And I think another new thing is that usually when people think about processors and myself, like we think about like different microarchitectural details, which instructions would be running at which part, right, of your processor. But it's not like that. It's actually can be so much beyond of just processor, which are like connecting different processors or connecting different accelerators and processors to each other. Yeah. So these are the differences, I guess. Yeah.
We had a question from Yakubov. Where can learn machine learning using Google Cloud courses? And I shared to this chat one of the course we're doing at Central Asia. Also, we can provide internships from partners from this IT companies in Central Asia. This is for Yakubov. Cool. There's some slide. And
I guess this is just like to explain the part how like hardware looks like these days. It's not about processor, but we have different accelerator. For example, GPU itself is an accelerator type because they can make this like heavy matrix multiplication or related computations so fast. And you can have accelerator for your encryption like SHA or AS as well. You can have serialization, deserialization stuff and as well. And in your software is also getting so hardly there is virtual machine abstraction. Network stuff is getting increased a lot these days. And you have different system services like memory allocation when you write your C code, or when your page fault happens in hardware, it should be served as well. Garbage collection in languages like Java or Python and related. And all these things did not exist for some time, but now they are evolving a lot, right? So you can offload some of them to the hardware, like not only having matrix multiplication computations, which are characteristic of machine learning, but you can offload like some system services too, and which comes back to hardware again, and it makes it even more heterogeneous. Here, heterogeneous means that your architecture of hardware comprises of not similar processors, but different processors and accelerators. And because you can now accelerate even more things than your machine learning model, now it becomes even more heterogeneous and it's hard to now manage it. And so this is my research. What is my research about? Yeah.
And nobody use assembler programming code?
Yeah, exactly. So like we all think that like our computer architecture is about assembly, right? No, it is not. Assembly is about something that you already built your processor, right? But how you come up now with new processor, where you don't need, so like it is different. And also like you now think about how to communicate between different processors, which can be solved via solutions that are not using assembly language. Yeah.
Thank you. Thank you. I don't have other questions. I will prepare for next meetup. Maybe we could repeat this for some specific area. Maybe Alina will also come up with some suggestion. I know we are all interested in deepening and continuing knowledge transfer, because Nazerke, you are in the cutting edge of research in general computer science, and people usually don't have access to this kind of insights. Maybe for you it's obvious stuff, but people watch from not only from Central Asia, people from Europe, some folks from Africa. Sometimes they type questions. We don't know how this YouTube algorithm works. So maybe somebody will add you on LinkedIn after the stream, because we shared your LinkedIn.
Yeah.
Thank you for your time.
Thank you, Nazerke.
Yes, thanks for inviting too. Like this was also my goal, because while I was in Kazakhstan, or like even at NU, when I had kind of professor who worked in the industry before, right? I didn't get all this information. Like, as I said, like I had so much limited view of what is being done. But now, after talking with so many people, both in the US and which are outside, now I can see that the research phase is so different, and now I could share it, I think. Yeah, so I'm happy for it.
Thank you. Bye-bye. Bye. Have a nice evening. Have a nice day, Alina. Bye.
Good night.
Good night.